Before you start watching this video, make sure that you have completed the little introductory activity on function composition. You should have found the link on today's date in the calendar. It should have taken you to a form, and you're trying to work through each page of the form. So pause the video or stop the video if you did not do the activity yet. That is meant to be a preview of today's concept, which is the composition of functions, sometimes called function composition. So what did you get from that little intro activity? Did you get the idea that that function composition is going to involve two functions? Did you get the idea that it will involve plugging into two functions? And did you get the idea that ultimately you're plugging a function into a function? Yes, all of those things relate to function composition, and they all begin with notation. The notation for function composition is going to be this symbol f of g. This symbol, this O that we have right here, f of, the O stands for of g. So we have f of g of x, which is the same as f of g of x. Now don't worry, I don't expect you to understand everything about this, but I do want you to see that it's new, it's different, and it's this idea of actually plugging a function into a function. And we describe that, we say that it is called f of g. Now, what you're going to find out is that when you plug a function into a function, you first plug into the g function. So it's kind of like we're plugging this ball into the g function. And then out comes, well, for this problem, out comes a cube. It's kind of interesting. And then, oh, look, we're going to plug a cube into the f function. And eventually, out comes this three-dimensional object. Yeah, function composition. It's plugging functions into functions, eventually getting some type of new output. Let's see how this works with some actual equations. So I have the function f of x equals 4x plus 3. And I have the function g of x equals x minus 2. If I want to do f of g of 5, f of g of 5, what I have to recognize here is that I'm going to be plugging into the g function and into the f function. But I want to make sure that I do this in the right order. And the right order is that you will always start on the inside. You always start on the inside, in this case, to do g of 5. Now, you can do g of 5 off to the side if you want. You can do it in your head if you want. All that's really going to happen is I'm going to plug 5 into the g function. I'm going to show it so that you can see how we get the number 3. We plug 5 into the g function, we get the number 3. But guess what? That means now that this g of 5 is the same as 3. And so it's kind of like I'm now being asked to do f of 3. See how I started on the inside? I got 3, and now I'm going to work my way to the outside, which is going to require us to do f of 3. What's f of 3? That's right, it's like plugging 3 into the f function. And when I plug 3 into the f function, I end up getting 4 times 3 plus 3, which of course just comes out to be 12 plus 3, ultimately equaling 15. 15 is the value of f of g of 5. Let's try another one. We've got some notation. G of f of negative 6, g of f of negative 6. You could rewrite this. You could rewrite it as g of f of negative 6, kind of like without the little circle. But again, the little circle just means of. Now I see f of negative 6. It's on the inside, right? We always start on the inside, so I'm going to now do f of negative 6. F is this equation. Oops, I'm going to need a little more space. F is this equation where we have 4 times whatever it is we're plugging in plus 3. So when I plug in negative 6, I get 4 times negative 6 plus 3, which is negative 24 plus 3, negative 21. Which means that f of negative 6 is the same as negative 21. So now it's like I'm being asked to do g of negative 21. What's g of negative 21? Well, just plugging negative 21 into the g function. What's the g function? Yeah, it's that function that says plug something in and subtract 2. And so when I plug in and subtract 2, I'm going to end up with negative 21 minus 2, which is negative 23. Negative 23 is is g of f of negative 6. And again, notice that I started on the inside. And then I worked my way to the outside to get negative 23. How about f of 7? F of 7. Even though it's the same function twice, let's go through, let's do it as we've done before. Let's plug in first to the f function. Now when I plug into the f function, one more time, that's the function where you take 4 times whatever you're plugging in plus 3. That, of course, is going to be 4 times 7, because that's what I'm plugging in. 28 plus 3, we get 31. Now, f of 7 is the same as 31. So what I can do is I can now think of this as f of 31. What am I going to do with f of 31? Same thing that we just did. You're going to plug that into the f function. This time, though, you're going to be taking 4 times 31 plus 3, which ends up being 124 plus 3, 127. We start on the inside and we work to the outside. You're plugging into a function and then eventually plugging into the you're plugging into the inside function. Eventually you're plugging into the outside function. You try. You see if you can figure out you can decipher the notation so that you can do both of these function compositions. Some students would like to rewrite. If you want to rewrite it, that's fine. You're ultimately going to be asked to figure out g of 6. Plugging 6 into the g function is going to give you 6 squared, which is 36, minus 3 comes out to be 33. It's kind of like saying that g of 6, which is exactly what it is, g of 6 is the same as 33, which now you're going to plug into the f function. The f function says to take 2 times whatever you're plugging in, add 4. 66 plus 4 is 70. Make sure you understand that 70 is your final answer. It's the value of f of g of 6. Remember, you want to try. So don't just keep watching. Make sure you pause the video and then try. See if you can figure out each of these function compositions. F of -7. Make sure you're plugging that into the f function. So you want to do that first. You always work on the inside first. So we end up with -14 plus 4, which is -10. If this is the same as -10, now we're going to be asked to do g of -10. When you plug -10 into the g function, it says that you're going to square and subtract 3. You're going to square whatever you're plugging in. Make sure that you do that first. That -10 squared is 100. 100 minus 3 is 97. Function composition. Basically plugging into the inside function, eventually working your way to the outside function. It always does involve two functions. We just want to make sure that we're doing that in the correct order. Now we can also do this idea of plugging in with different sort of givens. Just like the other day, we might be given a table. And so if I'm asked to try to do f of g of -2, I want to first do the g of -2. When I do that first, that's going to give me that's going to cause me to go over to this table, make sure I realize that -2 is the x value. So I got -2, and then my actual value of this comes out to be 3. So we're really trying to find f of 3. Now 3, do you notice now 3 is my x value? So I go over here to my f table where x equals 3. And I find the y value, the ultimate value, to be 1. Okay, so make sure you understand that the overall final answer to this problem is 1. Do you have to rewrite this? You don't have to, but it's supposed to help you see that we're going to do f of 3. We're going to do f of 3. Again, 3, this 3 right here is the x value. So I have f of 3 equaling number 1. Since this is equal to the number 1, now I'm going to think of this as g of 1. G of 1, when x is 1, tells me that the value is 6. Of course, that's the overall answer of the original problem. And finally, for this last one, when I do g of 1 means that x equals 1. So when x equals 1, my y value is 6. And now that means I'm going to do f of 6. So I go over here and find when x equals 6 on the f table. And of course, that means that the value will be 4. The overall answer, of course, being 4. You want to try a few? Yeah, try it. See if you can do hog of 0. Hog of 0. If you rewrite the problem, it is nice to do that. You can see that you're going to do g of 0 first. G of 0. G of 0 is -2. Which now means I'm going to ask to do h of -2. That means you're going to plug -2 into the h equation. That's going to cause you to do 1 plus -2 squared. And that, of course, is 1 plus 4, which equals 5. H of 2 means you're going to plug 2 into the h equation. We'll do that first. That comes out to be 1 plus 4, which is, again, 5. But this then means I'm going to try to figure out g of 5. That means I'll go to my g equation when x equals 5, get the value, which is 7. We can do this with graphs. It's still a matter of thinking about plugging in using the inside function first. So this means x equals -2 on the g function. Now when x equals -2, that refers to this point where y equals 1. 1 is the value of this g, so working to the outside, I now have to do f of 1. F of 1 refers to this point. That means x equals 1, so the value will be 3. Let's spice things up a little bit. Let's think a little bit backwards. Now, to think a little bit backwards, you notice that I'm giving you the answer. You want to realize that that's the answer of f. So it's kind of like saying that you need f to equal 3. You need f to equal 3. Wait a minute, when does f equal 3? Well, f equals 3 when y equals 3, which happens when x equals 1. So I need f to equal 3, and again, that happens when x equals 1. Now, working backwards, the next thing to realize is that I'm now to the inside function, but I got to go back to my need. See, now I need my inside function to equal 1, talking about the 1 that we found up above. So now the number 1 becomes like a y value. If I need g to equal 1, I'm talking about a y value of 1. Now, up here on this graph, a y value of 1 happens in two places, because right here y equals 1, but right here y equals 1. So we have two places where y equals 1. What does that mean? What do we mean two places? Well, we're talking about the x values at these two places, which happen then to be the answers to my final equation. But let's put this out. That happens when x equals plus or minus 2. And those would be the x values that I'm trying to find from the original problem. What do you think about my little need when? I encourage you to use that strategy if you're trying to work backwards. See if you can do 3 or 4. Work on the inside first, f of 0. F of 0, that means that x equals 0. X equals 0 on the f function. On the f function, x equals 0 right here. Definitely that's x equals 0, but its value is 2. So that means that f of 0 is actually 2. Of course, it also means I have to do g of 2. So go over here to my g function. I'm going to do g of 2. Remember now, 2 is the x value, and 2 is the x value at this point right here. So the value is 1. That is the value of g of 2. Backwards. Use my little strategy. How does this work? Okay, well, 0 is the answer, so that means that we need f to equal 0. Now, to say f equals 0 means that that's the y value. Okay, that's the y value, so that's happening right here. That's happening when x equals -2. Now I go to my inside function, which is g, and I say that I need g to equal that answer that we got to equal -2. So what's happening now is that -2, I'm referring to this -2, is now a y value. It's a y value on my g graph. Where's the y value of -2 on the g graph? Yeah, it's at both these places, when x equals 1 or x equals -1. So I need g to equal -2, but that happens when x equals plus or minus 1. Now, this officially concludes day 1 of your function composition pamphlet, of the function composition lesson. The homework for day 1 is right there on page 9. So you go to page 9 and you have the homework that goes with today's lesson. So check that out. Tomorrow we'll take a look at the next couple parts of this function composition concept. See you then.